In this video, we're going to create our third weapon component. This weapon component is responsible for defining the hitbox of our weapon, and will also be responsible for detecting things within that hitbox based on some action. In this case, for our swords, we want to check this hitbox whenever we actually swing the sword. So we will trigger checking this hitbox based on an animation event. So welcome to Barden, my name is Heinrich, and let's get into it. The first thing I want to do is create our new component. So let's head over to our editor, and in our file explorer, let's come down to our weapons folder, and then let's start with our smallest piece of data, the data for a single attack. So in our attack data folder, let's go ahead and create a new C# class. I'm just going to call it AttackAction hitbox, like that. So this class is responsible for defining the hitbox itself per attack. So because this is our attack data, we just need to make sure we remember to come and inherit from attack data. Then we can come over to our component data folder, right click on that, add a new C# class. And in this case, I'm going to call this class action hitbox data, like that. And now this class needs to inherit from our component data class, and we want to inherit from the generic version. And we're going to pass in the attack action hitbox that we created just a second ago. Then we can come over to our components folder and finally create the component that will actually sit on our weapon game object. So hit add, new C# class, and this one I'm just going to call action hitbox. So you can see again how we're following along with our naming convention. We have our component action hitbox. We then have the data for that component, which is action hitbox data. And then we have a single attacks data, which is attack action hitbox. Now I use the word action in these classes because our weapons will have a action animation event, so the main action of this attack. So we still need to go ahead and actually create this animation event. To do that, we need to come over to our animation event handler that we created earlier in the series, and we're going to add a new public event and a new trigger function for it. So our public event is also going to be of type action, like the others, and we're going to call it just on attack action. We can then come down to our functions and simply say private void attack action trigger. And all this function does is it simply invokes our on attack action. So this is the animation event that we're going to subscribe to check our hitbox. So let's come back to our hitbox component. And in here, let's create the function that'll handle when this animation event happens. So we can create a private void, and I'm going to call it handle attack action. And now we need to go ahead and subscribe this function to the event that we just created. Except I just noticed I forgot to inherit from our component over here. So we just need to go ahead and say weapon component, and we're using the generic version again. And to this, we need to pass in what our data is. So that is action hitbox data. And then our singular attack data is simply attack action hitbox. So now, because we are inheriting from weapon component, that already gives us access to our animation event handler. So let's go ahead and subscribe this function to those events in our onEnable and onDisable functions. So let's go ahead and override our onEnable. And after base.onEnable, we can say event handler.onAttackAction plus equals our handle attack action. Next, let's override our onDisable function. And in here, we simply say event handler.onAttackAction minus equals handle attack action. Now, before we do anything else in here, let's just go ahead and head back to Unity, and let's add our animation events to our animations. So we can do this for now by clicking on our player, coming to either our primary or secondary weapon, and then the base game object under that. That'll give us access to our animation tab over here. And for our sword attack 1, we want to call this animation event right over here. So this is where the sword strike happens. So let's just go ahead and add a new animation event over here. And I'm actually just going to bring the inspector down here again, so I have less editing to do later. So we add an animation event on our third frame, or fourth frame in this case actually, and go ahead, come down to our function dropdown and select attack action trigger. Then we can do the same thing for attack 2. For all of these animations, we want this animation event at the same place. So add a new animation event, select the function, come to our next animation, come to this, in this case, the 5th frame, add a new animation event and select our attack action trigger. Perfect. So now would be a good time to just quickly make sure everything is working. So if we come to our sword 1 asset over here, you can see we have automatically generated a new button for our action hitbox data. Let's click that and add a new element, and we're not going to see anything because we forgot to tag it as serializable. So let's quickly come back to our editor, come to our file explorer, and then come to our attack action hitbox class over here. And we just need to add the serializable attribute. Now, before we go back to Unity, let's also actually just come back to our action hitbox class, and let's just debug something in our handle attack action. So I'm going to say debug.log handle attack action. Okay, so now back in Unity, everything should be fine. If we take a look at our sword 1 asset, and then go ahead and add our action hitbox data in again, there we go, we can actually see it now. So we have 3 attacks, and these elements aren't going to show anything yet because we haven't defined any of our hitbox data yet, but we just need to make sure that the array has 3 elements so that we don't get any errors. Then we can come to our sword 2 asset, do the same thing, add our action hitbox data, and add 3 elements. So now before we can run it to test it, we also need to come to our 2 weapon game objects over here, select both of those, hit add component, and add our action hitbox component like that. So now if we save this, and we go ahead and run the game, when we attack, there we go, handle attack action does get printed. Okay, so our animation events are working properly. Let's move on. So let's think about what sort of data we need for this hitbox. Well, we need to define the width and the height of the hitbox, and we also need to define an offset from our player's transform for that hitbox. And then the last thing we need to define is the layer mask for what items are actually detectable. So let's come back to our editor, and let's come to our attack action hitbox data. And in here is where we define the width and height and the offset. Now we can do this by simply defining a single rect. So let's open up some square brackets, say field, serialize field, so that it'll show up in the inspector, public rect with a capital R, and we'll just call it our hitbox. And then don't forget to give it the public getter and the private setter. Now you can see if we hover over rect over here, it is a 2D rectangle that has an X and Y position and a width and a height. So all the information that we need for a hitbox. Now for our layer mask, instead of defining it in here on a per attack basis, we can define it once for the entire component. So let's come over to our action hitbox data over here. And inside this class, we can again define a field, serialize field, public, layer mask, and we'll just call it detectable layers. And then don't forget to give it the public getter and the private setter. Let's just go ahead and save this and confirm that we can see this in the inspector now. So if we click on sword 1, we've lost our elements, but that's okay. There we go, we have our 3 rectangles for our attack, and then over here are detectable layers. Perfect. Now before we fill in any of this data, how do we actually make use of this data to detect something in front of our player? Well, to do this, we're simply going to make use of the physics 2D.overlap box, which takes in a position, a width and a height, and a layer mask, and we will store whatever that detects. Now to do this, we always want to detect in front of the player. So that means that our action hitbox component needs to have access to our player's facing direction through the movement core component. So before we can add any of the actual detection logic, let's go ahead and give our action hitbox component access to our movement core component. So let's come back to our scripts, and how we usually give something access to our core. Let's take a look at our script real quick and see if we can find a good example. We can probably make use of our other cores, let's say our collision senses, because this is essentially what we're going to do. You can see over here our collision senses has a private movement, which simply checks to see if another movement variable is not null, and if it's not null, it returns that variable, but if it is null, it goes ahead and sets the reference. So in a previous video, we've already given our weapon system access to our core. Let's take a look at that real quick. So if we take a look at weapon, over here we have our public core, because we needed it in our movement component over here to actually apply the movement velocity. Now, I'm getting kind of tired of having to write this every time I want to access a core component. So I think it might be time to create a new class that'll take care of this for us. So let's come back up to our core folder over here. I'm going to right click on that and add a new C# class, and I'm going to call it core comp or core component. Now, this is going to be a generic class where we can create one instance of this class to take care of all that other logic for us. So we're not going to worry about replacing everything we've done so far with this, but moving forward, we'll be using this, and then if we work on a script and we see that it's using the old way of doing things, we might replace it there. But so like I mentioned, this class is going to be a generic class. So we open up some angle brackets there and put t as our generic type. And then we need to limit the scope of our generic type to being a core component. So we'll say where t is a core component. So what does this class need? Firstly, we need a reference to the core where we're going to check for our core components. So let's create a private core called core. And then next we need a place to actually store the component. So we'll say private t, because t is our generic component type. I'll just call it comp. Next, we need to create a way of accessing this component and implement the logic for getting the component from the core if it does not exist. So what we can say is public t, because we're returning our core component, call it comp with a capital C, and this is just simply going to say comp, comp, core, dot get core component with a reference to our comp. So exactly the same as we have everywhere else. But now hopefully we'll never have to write this line of code again. Now the final thing that we need to make this actually work is we need to set our core reference, and we'll do it in a constructor for this class. So go ahead and say public core comp, and this is going to take in a core that we'll just call core. And then in here, all we'll say is this.core equals core. Now, maybe just to be safe, we should do a null check on core and debug a warning if core is null, because that'll break everything for us. So let's just say if core equals null, then we're going to say debug.log warning, and we want to write $, just to make it a formatted string. Core is null for component, and let's pass in the type of that we're trying to store. So hopefully this will help us figure out where things are going wrong. But we should be able to use this class now. So how do we use this? Well, let's go ahead and set a reference to our movement core component in our new action hitbox component. So let's come down to action hitbox, and all we need to do is declare a new variable that is going to be private core comp, this new class that we just created. And to this, our type is going to be core system dot movement. So remember, we're just saying core system because of our namespace. If you're not using namespaces, you can probably just say movement in here. But we just need to differentiate between our movement weapon component and our movement core component. And so then we can just call this variable movement. So now we need to initialize this variable with our core. And because our core is set during the awake on our weapon class, let's go ahead and set this in start. So currently our weapon component class does not have a start function. We have a virtual awake function, but not a virtual start function. So let's just go ahead and create that here. That way, if we ever have to use start in any of our other weapon components or need to do something in start for our base classes, we don't have a bunch of refactoring to do. So let's just go ahead and create a protected virtual void start. And then we can come back to our action hitbox class. And in here, let's go ahead and override our start function. So let's say override start. And then in here, all we need to say is movement equals a new core component And in here, we pass in our core, which we already have a reference to because of our weapon component class. Let's go ahead and in our handle attack action, let's just go ahead and debug our facing direction just to make sure that we have everything. So we'll say movement dot component, accessing the component in that class we just created, dot facing direction. So if we save that and come back to Unity and now run the game, when we attack 1, -1. Perfect. So we have a reference to our movement core component now. So with that done, we're ready to create the actual logic for our action hitbox class that makes use of our rect and layer mask. So let's come back to our script once again. And in here, instead of debugging our facing direction, let's go ahead and see how we detect something within that rect. So we can say physics2d dot overlap box all, because we want to detect multiple colliders and not just the first thing that we find. And in here, we need to pass in a point, which is the center of the box, the size of the box, the angle will just be 0 because we're not rotating the box or anything, and the layer mask. And you can see that these functions return an array of collider 2D. So let's start with the first thing. Where do we want the center of this box to be? Well, we want this point to be some offset off of our player's transform. And so usually our hitbox is probably going to be in front of our player, meaning that whenever we rotate our player, this offset is actually going to change on the X. So we're going to be making use of the X and Y point in the rect as our offset, but we need to flip it on the X depending on our facing direction. So let's go ahead and just quickly create a variable that is going to be private vector2 called offset. And in our handle attack action function, let's start by setting this offset with offset.set. And on the X, we're going to set this equal to transform.position.x plus our current attack data dot hitbox dot x multiplied with our movement dot comp dot facing direction. Then for our y, we're going to say transform dot position dot y plus our current attack data dot hitbox dot y. So this will make sure that we're just flipping the x of our hitbox offset based on our facing direction. So now we can go ahead and pass this in as our point, so offset. And then for our size, we can go ahead and just say current data dot hitbox dot size. Next, for our angle, we can go ahead and just say 0f. And then finally, for our layer mask, we can say data dot detectable layers. And so remember that our weapon component class that we are inheriting from is taking care of all the logic of setting our current attack data and our data itself. So that should take care of detecting anything within our rect. Next, we just need to store that somewhere. So let's go ahead and create another private collider2D array, and we'll just call it detected. And let's set what overlap box all returns equal to detected, or set detected equal to what overlap box all returns. And so now previously I mentioned that this component only takes care of the detecting things within the hitbox. It doesn't hold any of the logic for damaging it or knocking it back or things like that. So what's going to happen is this component is going to broadcast whenever it actually detects something, and other weapon components can then listen to that broadcast and do things to the things that this component detected. So to broadcast it, we're just going to make use of another simple event. So let's come back to the top of our variables, and let's create a private event action. And in this case, instead of not having any input type, we're going to use this generic version of action, and we're going to set the type to collider2D array. And then we're just going to call it onDetected collider2D. So now to actually invoke this event and pass our detected into it, let's come to the end of our handle attack action function. And first, let's just make sure we actually detected something and that this array doesn't have a length of 0. So we'll say if detected.length equals 0, then return. We don't want to do anything else. Otherwise, onDetected collider2D null coalescing operator invoke. And now you can see that invoke is expecting a collider2D array, so we can just pass in detected. Now in this video, we're not going to be creating another component to handle this, so let's also just actually go ahead and loop through our detected and print the items that we do detect just to make sure everything is working. So after invoking this event, I'm going to say for each, and the collection we're going to loop through is our detected array. We'll keep it as var, and I'll just call it item. Inside the for each, we can then say debug.log item.name, just so we can make sure everything's working. Now, the last thing we need to do before we can actually test to make sure our detection is working is if we come back to Unity, we have no way of knowing what this data actually means. We cannot visualize our hitbox yet. So we need to go ahead and make some gizmos for that. Let's come back to our editor once again. And what I'm actually going to do is come to our AttackAction hitbox class in here. And I'm just going to create a public bool called debug. And then back in our action hitbox class, we're going to only draw our gizmo for the attack that the debug is currently true for, just so that we're not drawing the hitbox for all 3 attacks at once. Let's come down to the bottom of our class, and let's create the onDrawGizmosSelected function. So we can say onDrawGizmos selected. And so that means we will only draw the gizmos when we actually have the game object selected, so it's not always drawing our hitbox. And in here, the first thing we want to do is check to see if our data is null, because we don't have any of the information if our data is null. So let's avoid throwing any errors. So let's say if data equals null, then just go ahead and return. Don't try and draw anything. So with that done, we can now go ahead and loop through each attack in all of our data. So let's say for each, and the collection that we want to loop through is our data.attackData. And we can just say var, and I'll call this item once again. Now in here, what we'll do is we'll say gizmos.draw wireCube, and to this we're going to pass in transform.position plus item.hitbox.center. So .center is essentially returning both this x and the y as a single vector 2 instead of 2 separate floats. But you'll see that this is giving us an issue because center is a vector 2 and position is a vector 3. So we just need to go ahead and cast this as a vector 3. And that should be good for the center of our wire cube. Next, we just need to pass in the size of the cube, which is again just going to be item.hitbox.size. And actually, before we do this, we also want to not call gizmos.drawWireCube if debug is false. So we'll say if item.debug, then draw this gizmo. Or maybe a better way of saying this is if not item.debug, then continue. Just so that we have a little bit less nesting. So for every item, if the debug is false, it'll continue to the next iteration of the for each loop. Perfect, well, let's see if this is working. If we come back to Unity, let's go ahead and lock the inspector with our sword 1 selected, because we need to come to our weapon itself and click on that to actually have the gizmos drawing. But now, we unfortunately can't actually set this data while the game isn't running because our code kind of takes care of setting the data at the start of the game. But luckily, because we are also working with scriptable object assets, any changes we make at runtime will persist, so we don't have to worry about copying and pasting things. We can just go ahead and run the game. And let's come over to our scene. Now, it's not currently drawing anything because none of our elements are debugging. So let's enable debug for the first attack. And let's increase the width. You can see there we have that little white line. Increase the height. And let's just create a nice hitbox for our first attack. Let's take a look in the game view. So there we can see what the hitbox of our attack is. Now for our first attack, that doesn't look too bad. We just need to increase the width a little bit more. I think that's pretty good width. Let's take a look for our second attack. I actually think for our first and second attack, we can use the same hitbox, such as copy and paste that in there. That looks good. Now for our third attack, we attack a little bit closer. So something like that maybe, and a little bit up. Now you could totally use the same hitbox for all three attacks. I think that's fine, but that should be good. Branded. Because our other sword is just a reskin of this sword, we can use these exact values for that one as well. So let's go ahead and stop the game. As you can see, we still have all of these values. And let's just go ahead and copy this attack data, come to sword 2, unlock our inspector, and let's just go ahead and paste that in here. Now, the last thing we need to actually remember to do is to set our detectable layers. Currently, it is set to nothing. We can go ahead and click that and set that to damageable. Do that for both weapons. So really now we should be able to try it out. Let's go ahead and run the game. And we want to see it detect our combat dummy. There we go. Combat test dummy has been detected. Let's see for our enemy 2 that has been detected. And our enemy 1. Now, as you can see, over here, we have detected multiple items for our enemies. We've detected the combat game object and the enemy 2 game object because they both have colliders on them and have been set to the damageable layer. If we take a look at enemy 1 over here and come to core, you can see combat is set to damageable and has a box collider 2D, and enemy 1 is set to damageable and also has a box collider 2D. Now, this is fine because whenever our other components make use of the detected items, it'll be looking specifically for the eye damageable interface. But there we go, so we have our hitbox set up now. In the next video, what we're going to do is see what more we can do to just help organize our inspector over here. As you can see currently, we have element 0, element 1, element 2. We have no way of knowing what these components are unless we come and take a closer look. And even if we expand each element themselves, we still need to expand an actual attack to see what component this data is for. So in the next video, we're going to take a look at just renaming a bunch of these things in the inspector, and also a way of just making sure that every element has the right number of attacks whenever we add it, and fun stuff like that, just to, again, help things get a little bit more organized. And so that's going to do it for this episode. If you would like early access to the source code of the prototype that I'm using for this project, it is available to all of my Patreon tiers over on Patreon. And with that being said, I would just like to say thank you to all of my supporters and wonderful people over on Patreon. And a huge special thank you to Cody Lee, SM, Major Sins, Jake Skarupa, Patrick, Atami, Mike Rodriguez, Nathan Ackley, and 12 Feet Up. You guys are absolute mad lads, and I hope you all have a wonderful day.